we'll go through the official website of Plotly, and yeah. So Plotly, as we discussed yesterday, it's very useful for these kind of figures, like which are interactive in nature. So you can hover over the plots and you can see what is there in the data. So there are two ways. One is plotly.express, then another is plotly.graph objects. So we'll see both of them. Now, if you want to plot a line using plotly.express, you would simply say px. So import plotly.express as px, and then say px.line. So then you give your x and your y. That can be a list or a numpy array, and you can also give title. So this is that title, and you can save your figure as well. So you can just say fig dot save fig, and then uh, you can save it as either png or. So then we were discussing about Dash yesterday. So Dash is a way to basically build analytical apps in Python using Plotly figures, and to run the app below, run pip install Dash, click download to get the code, and run Python app. So let us do that. So we see that we have downloaded this, and now so let us please see this. Okay, what I will do is I will create an environment for okay, so this environment we are creating. Yeah, so we can just open environment and let's say pip install dash. So we are following okay, so it says run pip install dash, click download to get the code and run python app.py. Plotly requires pandas. Okay. So it's created a Flask app for us, which is available on this link. So you can just go here, click this. So you can see that this app has been created in so Plotly. Plotly has created this app for you, and this I think is the HTML that. So we will see what is there in this code. So you can see that we have to first import dash from capital DSH dash from dash, and some other things like DCC, HTML, input, output, and you get plotly.express as px, import JSON, So JSON is, if some of you might who have done data analysis might be knowing that JSON is a file format in which you can also save the data. So we plot the line with using fig. So px dot line x equal to abc, y equal to 1 to 3, and we say title equal to sample figure, height equal to 325. And now we create this app. So app equal to dash underscore underscore name underscore underscore name. That's the syntax you give for the for this app. And then you give an app layout. So app dot layout equal to html dot div, displaying figure structure as JSON. So you can see here we are getting this title here. So displaying figure structure as JSON, and this is having h4. So there are different headings in HTML. So we are giving h4 here, h1, h2, h3, h4 based upon the size is. And then you say DCC. So this DCC you also get from dash. You say DCC dot graph ID equal to figure structure x graph figure equal to fig. So this is the figure handle which you will get from here. And then DCC dot clipboard target equal to structure HTML dot free figure. So you then give some style, so border, and then the height and overflow y. So then you have to define this. We have this decorator at the rate app dot callback. So this decorator is over this function display structure. So you can see that in this we use this output class and input from which are also we import from dash the output and the input. And so you say figure structure x structure output so comma children, and figure structure x graph comma figure. And then okay, so this is what you get in. So like display structure fig underscore JSON, that's the argument you get in the display structure. And then this using this JSON dot dumps, so you dump this like this fig underscore JSON, and then you run this app. So we created this app. Okay, we made the layout, and then we defined this function, and then you say app dot run server debug equal to true. Now if you run this, this will create this uh, this link. So this is creating an app, I think, in Flask. And so you are running this server here, and so this will show you will show you the data. So it says, yeah. So we will see further. So that's what we did. We downloaded this and it plotted this figure for us, and also dumped the data here. Now, figures has trees of attributes. So plotly.js supports inputs adhering to well-defined schema, where overall architecture is explained in this page, which is exhaustively documented in figure reference, which is itself generated from a machine-readable JSON representation of schema. So we will see these things. We will see the okay. So then, yeah, we already saw Dash is an open source framework for building analytical platform applications with no JavaScript required. So you don't have to explicitly code in JavaScript. Dash will take care of for you, and it is tightly integrated with the Plotly crafting library. And we have already installed Dash. And everywhere in this page, if you see fig.show, you can display the same figure in Dash application by passing it to figure argument of the graph component. So you can see here. Now, just like plotly.express, you can create your figure using plotly.graph object. So this is our figure. We do some things, create the figure, and then we get these DCC and HTML from Dash, and then you create a Dash app, and then you have to define this layout. And inside, they are saying inside this the graph component, you have to pass your figure as an argument. And then if you do app.run server, this will basically run your this will run your server. This will be like class server that you are running. So then the next is creating and updating figures. Okay, so figures as dictionary. So figures at low level, figures can be represented as dictionary and displayed using functions from the plotly.io module. Quick dictionary in this example below describes it. So okay, so let us see this. Now this is a we are creating this. This is a dictionary. We're saying okay. So in this one we have the key as data and layout. These are the two keys. And so as you know, in dictionaries you can have unstructured data sets as well. So you can see that this this layout, key layout, the value of this is another dictionary, but for this data the value is a list. Now in this list also we have a dictionary with keys as type is var, x is 123, y is 132, and you have the title as okay. So then this is another dictionary. Okay, so which has the key as text and title is and the value is a figure specified by Python dictionary. So so it says at the base level, fig is also the figures that we plot are actually dictionaries. You can access can go and try to plot matplotlib figures and then try to do fig.data and fig.data.type. So to try to access the data sets. And then if you just import plotly.io as PIO, PIO.show fig. So this will just plot here uh, this fig dictionary. Second is figures as graph objects. So the plotly.graph object module provides an automatically generated hierarchy of classes called graph objects that may be used to represent figures with top level class plotly.graphObjects.figure. So this plotly.graphObjects.figure will be used to plot the figures. And so to note that the recommended alternate to working with Python dictionary is to create entire figures at once using Plotly Express and then to manipulate them using plotly.graphObjects.figure objects as described in this page wherever possible. So graph objects have several benefits as compared to Python dictionaries. They provide precise data validation. So if you provide any invalid property name or invalid property value as the key to a graph object, an exception will be raised. So it's easy to basically debug when you are using these graph objects. Graph objects contain descriptions of each valid property as Python doc strings with a full API reference. So it contains this full all the functions are defined. You can see what they can do. It's got a reference. Uh, and you can, as we had seen, so you can just put a question mark and then it will give you the doc strings of that function. If you are struggling to find out what that is actually doing. Properties of graph objects can be accessed using both dictionary style key lookup. So you can say fig dot layout or fig square brackets string as layout or class type. So you can or either say fig dot layout. And graph objects support higher level convenience functions for making updates to already constructed figures. So you can just say dot update layout or dot add trace, and we'll see this below. Graph objects, uh, object constructors and update methods accept magic underscore. So for example, go dot figure. So this figure this Go is graph object which is taken from Plotly, and we have already read that graph object dot figure is used for plotting, and layout underscore text title underscore text. So you can actually just so rather than having this kind of dictionary under a dictionary, so as you saw here, so this layout and then title and then text, so, so these were all dictionaries under dictionaries. You can use this magic underscores, and then you can just try on your own rather than even uh, going to the tutorial or reference. You can just try things on your own and see if they work. And they support rendering, attached rendering using dot show and exporting function. So dot write image that automatically invoke the appropriate function from plotly.io module. So let us see. Now you import plotly.graph objects as Go, and you say fig equal to go.figure. So this is your data. So in the data argument, you give the data. You say go.bar. So we want bar plot, and x equal to 123, y equal to 132, and what is the layout that you want? So go.layout. So that is what we are defining. And in go.layout, you have to define this title argument, and you can say go.layout.title text equal to a figure specified by graph object. So then this will plot you this kind of a bar plot. This was same as this big dictionary wherein you were. It was quite. It's quite. Doesn't look that neat. Like you have to define a dictionary under a dictionary and do various things manually. So then you can also create a graph object from a dictionary representation by directly by passing the dictionary to the go.figure constructor. So you can just directly have this dictionary as we saw before, and you can just say go.figure, and you can just pass this dictionary of figure, and you can just say fig.show. Now converting graph objects to dictionaries and JSON. So we have seen how to plot the graph objects. So go.figure data equal to, and in the you will pass a list. So you say what is the type of plot you want, and then layout, the layout that you want, and so you can also update the layout template, and you can print the dictionary represented by this graph object figure. So you can say dictionary representation of graph object. So it's fig dot to underscore dict. So this function to underscore dict, this will convert this figure object into back to a dictionary. So you can see that it is printed here as a dictionary, and you can also have a JSON representation of this dictionary. So you can see that you get this JSON representation. So to underscore JSON, you can save this as a JSON file. And how to represent this as in dash. So like we have seen, so you make this figure, create this dash app, and then inside, so this graph, inside the graph uh, constructor, so you have to pass this figure equal to fig argument. Okay, so then Plotly Express. So this section summarizes several ways to create new graph objects with the plotly.py graphing library. So Plotly.express is a high-level data visualization API that provides fully populated graph object figures in a single function call. So you can see you are getting this plotly.express as px and df equal to px.data.iris. So this iris data frame, pandas data frame, you are importing from plotly.express, and then you are creating this figure fig equal to px dot scatter. So you can just directly say just like we use in matplotlib or c1, you can just say px dot scatter. This, what is your data frame, what is your x, what is your y, the color, you can see this is the hues. Okay, so the hues you are defining based on the species, and the title. And then you can simply say fig.show. So this will plot by on x-axis is sepal width, on y-axis is sepal length. So these are the name of the columns, sepal width and sepal length. The hue here or the color here is species. So you can see, you can hover around this plot. You can even there are different methods by which you can even zoom around. Okay, so you can just go ahead and then uh, so there is, yeah, so there is this one reset axis. So it just reset your axis. You can download this as a PNG. So you can just see this. This is your PNG plot. Now graph objects as figure constructor. So as demonstrated above, you can build a complete figure by passing trace and layout specification to plotly.graph objects dot figure constructor. So we have seen this go.figure, you pass this data equal to, you pass a list and then say go.bar, and then you pass this, you have to give this layout argument in which you pass a dictionary. So then you say fig.show and it will plot this bar plot for you. And if you want to, if you can do make different types of plots. So figure factories are functions that produce graph object figures often to satisfy the needs of specialized domains. Here is an example of using create quiver. So you can see we are having this in NumPy, we are importing NumPy and from plotly.figureFactory. Plotly.figureFactory we are importing as FF. Now we create a mesh grid. So x1 comma y1 equal to np.mesh grid. So from x is from 0 to 2, spacing is 0.2. Y is also from 0 to 2, spacing is 0.2. Now you create this u1 and v1 velocity. So that is basically cos of x1 into y1 and cos of sine of x1 into y1. Now to create this kind of quiver plot, you have to give x comma y comma u comma v. And this kind of quiver plot you can also make in Matplotlib, or you can use Xarray. So when you are doing, so you have to just say dot plot dot quiver in Xarray. So Xarray data array dot plot dot quiver, and then you just have to give your u and v and your name of your latitude or longitude. So name of your x-axis and y-axis, and it will plot a nice quiver plot for you. So you can see that create underscore quiver. This will create this quiver plot for you, and you can go here and see the start and the end point of these quiver plots. You can also make subplots. So for that you will use plotly.subplots. Um, so from plotly.subplots we extract this make underscore subplots. So say fig equal to make underscore subplots, rows equal to 1, columns equal to 2, and then you say fig dot add trace. So to this entire figure you make this add trace. Go dot scatter. So this first argument is what you want to plot. So you want to make a scatter plot, and y equal to 4 comma 2 comma 1, mode equal to lines. So what is the row and column? So row equal to 1, column equal to 2. So you get this, that's the first subplot. And then again fig dot add trace, go dot bar, y equal to 2 1 3. And then for what you want to plot this, you want to plot this for row equal to 1, column equal to 2. You can do different things. You can zoom, pan, box select, and then zoom in, zoom out, reset, and you can also download it as PNG. So then, so regardless of how graph object figures were constructed, it can be updated by adding additional traces to it and modifying the properties. So adding traces, so new traces can be added to graph object using add trace method. So this method accepts a graph object trace and adds it to the figure. So what is a graph object trace? Go.scatter, go.bar. This allows you to start with an empty figure and add traces to it sequentially. The append trace method does the same thing, although doesn't return a figure. So you can see here, you are importing plotly.graph objects as geo. Now you are creating this figure, go dot figure, and then you can add trace to it. So you are adding this go dot bar, so it is getting added to your figure. So you can also add traces to a figure produced by a figure factory or Plotly Express. So we are having this Plotly Express as px. This is our data set, pandas data frame, px.data.iris, which has got a lot of flower data sets. So now you create this scatter plot. So you say equal to px.scatter, and so we have seen this. And then to this same figure, if you would like to add trace, if you would like to add another plot, so you can say fig.add trace, go.scatter, x equal to 2 comma 4, y equal to 4 8, and then mode equal to line. So this is so you see 2 4, and then 4 comma 4 comma 8. So that, so with between these 2 points, it will create a line, and then so line equal to go dot scatter dot line. So you give the color as gray, and show legend equal to false. So that should not show any legend for this line. So in this same plot, you can see that you have added this trace. Now, how to add trace to a subplot? So you can see we make these two subplots. Okay, so these are our subplots, which you make using by passing the row and column argument. Now to add trace to this subplot, so you say, okay, so reference line equal to go dot scatter. So it starts from 2 comma 4 and z 4 comma 8, and in this one we can see that, okay, so fig dot address, you say reference line, comma row, comma row equal to 1, comma column equal to 1, and so this one, it plots this first subplot for you, and then yeah, this is the second subplot, and then this is the third subplot. Okay, so address convenience methods. So as an alternative to address, graph object figures have a family of methods of the form add underscore, where trace is the name of the trace type. So you can also say add underscore bar. So that will, so rather than saying add trace, so this graph objects library has this kind of family of methods or functions for constructing and adding traces of each trace type. So you can see here, you can either say add scatter, you can say add trace. So you can give row equal to row equal to 1, column equal to 1. And then making underscore notation. So to make it easier to work with nested properties, graph object constructors and graph object methods support magic underscore notation. So this allows you to reference nested properties by joining together multiple nested property names with underscore. So for example, while specifying the title in the figure constructor without magic underscore notation requires setting the layout argument to dict title equal to dict text equal. So this is not looking that clean. So rather than this, you can just say layout underscore title underscore text. You can just directly say this, and this saves you the work of making this dictionary of a dictionary of a dictionary. So yeah, that's a property of yeah. And then graph object figure support an update layout method that may be used to update multiple nested properties of the figure layout. So you can see here, you make this graph plot, bar plot. So go dot figure data equal to go dot bar, and then here we are not providing any layout information, but we can just say fig dot update underscore layout, and then you can pass these arguments: title underscore text, title underscore font underscore size. So this is the title, and this is the title text size you have got. Now note that the following update underscore layout operations are equivalent. So you can see that title underscore text You pass this title underscore font underscore size. So title underscore font underscore size equal to 30. This is equivalent to title underscore font equal to text size equal to 30. Or if you say uh, you can write rather than saying title underscore text, so you can say title equal to dict. So then like yeah, dictionaries of dictionaries and graph objects support an update underscore traces method that may be used to update multiple nested properties of one or more of the figure's traces. So you can see we make subplots here, so which has got one row and two columns, and you add a scatter plot here. So fig dot add underscore scatter. What is your what are your markers here? 4 comma 2 comma. So this is 4. This is 2. This is 3.5. And marker equal to so size equal to 20, color equal to light sea green. So this is your set plot. And the name, so the name is A. So for this is A, and row equal to 1, column equal to 1, and then you can say fig dot add bar, so you can add a bar plot to this. So and this bar plot, so you are saying color is medium purple and the name is B. And similarly, so but this one you are adding to row equal to 1, column equal to 1. You can add a scatter plot to row equal to 1, column equal to 2, add a bar plot to row equal to 1, column equal to 2, and then do dot show. So this one, by this you can see that you are updating to the traces, and you can see this legend also is coming on the right. And so note that both scatter and bar traces have a marker dot color property to control their coloring. Here is an example of update traces to modify the color of all traces. So here you see the marker colors. You see we are putting light sea green, medium purple, light sea green. You see here these are the colors. But now you can update to the for the entire figure. You can say fig dot update traces marker equal to color equal to royal blue. So all the colors have been changed to royal blue. And so yeah, this is also similar. So they are showing the example of update traces. Hmm. Okay, so update traces method can also be used on figures produced by figure factories or Plotly Express. So you can see that this is a figure which is uh, which is produced using Plotly Express, and on x-axis we have sepal width, on y we have sepal length, color we are representing with species, and facet column equal to species. So we are saying that you make the uh, different columns corresponding to different species, and you also plot a trend line. So this is the trend line that has been plotted, and this is using ordinary least squares method. So the title is using update traces with plotly. So in this one also you can just update the like for the entire figure you can use update traces, and then you can say line equal to dash equal to dot, so you are using this dot, and width equal to 4, and so selector equal to type is scatter. So you can update for graph objects, you can use update traces, you can use for plotly express. And so you can see we have made a bar plot here, and then the marker color was red. Okay. Uh, so then we say fig dot update traces overwrite equal to true, marker equal to opacity is 0.4. So it should be actually red. Anyways, but you can see that this bar plot is not entirely opaque. For example, these bar plots were completely opaque, but the transparency of this bar plot you have set it as 0.4. And yeah, we'll see the next thing now. So how to display figures in Python. So Plotly is Python graphing library plotly.py gives you a wide range of options for how and where to display your figures. In general, there are 5 different approaches you can take in order to display your figures. So using renderers framework in the context of a script or a notebook. So that's the main topic that we'll discuss here. And you can either use dash in a web app context or using a figure widget rather than figure as an IPy widgets context, or by exporting to an HTML file and loading that file in a browser immediately or later, or by rendering the figure to a static image using Kaleido. Okay, so such as PNG, JPEG, SVG, PDF, or EPS, and loading the resulting file by any viewer. So this is important. You can either just click that, download as PNG, or you can use this Kaleido. You can install this as pip install Kaleido or using conda install, and then you create your figure. So let's say we create this figure and we make this as a scatter plot. So the size is based on the randomly based on the SC. The colors are random. You can see we are plotting x comma y, and then to write this now plotly dot write io dot write image function is used to write an image to file or file like Python object. You can also use dot write underscore image graph object figure method. So that you can use fig dot write image, and you can also write it as webp, and you can save it as svg pdf, and you can see we can render this as an image in dash or as an interactive plot in dash as well. So you can, yeah. So for using this right image, you have to for using this write image function, you have to install the Kaleido library. That's the main point here. And now displaying figures using the renderer framework. So yeah, this one we have seen making the bar plot. So then in most situations you can omit the call to dot show and allow the figure to display itself. So you don't need to always say dot show. If you just say fig, then also it can display. And setting the default renderer. So the current and available renderers are configured using plotly.io.renderers configuration object, and display the object to see the current default renderer and the list of all available renderers. So you say import plotly.io spio, and you can see the different renderers available: plotly underscore mime type, Jupyter Lab, and tracked VS Code. And you also have thing known as, yeah, browser. So then if you import plotly.io as PIO and you set the default renderer as browser, so it is also possible to set the default renderer using system environment variable. Then overwriting the default renderer. So this is a figure displayed by the SVG renderer. So you can see here, you can make this figure. This is a bar plot, and you can say fig dot show renderer equal to SVG. So now you can see that we cannot see the values. We are hovering over it, but since this is an SVG renderer, and then there are different renderers: Kaggle, Azure, Notebook Connected, Colab. Okay, and then this is a PNG renderer. So figure displayed with a PNG renderer, and then you can do the same thing in Dash. So then Plotly Express, we will see Plotly Express very quickly. Is there any question you guys have? Hmm. So you can do various things using plotly.express. You can say px.scatter, and then px dot scatter. You can also then like so we are saying here x is sepal width, y is sepal length, color so the hue that you give in Seaborn, color is species, marginal y equal to y length. So you are making this as a y length plot, and marginal x is box. So you are making a box plot here. So you can see that these are your box plots. These are your uh, these are your y-length plots, and trend line equal to OLS. So you also want the trend line to be plotted, and template is equal to simple white. So this produces this nice looking plot for you. And then you can also say dot. So it can also plot the error bar for you. So we are loading this data, and then DFE, so which is the error bar, is equal to sepal width by 100. And then you can say error underscore x equal to E, error underscore y equal to E. Okay, so now this one, what this will do is this will plot the error bar as well for you. Like rather than just making this, you can see that. Okay, we will zoom this and see. So you can see that you're having an error bar in the X and you're having an error bar in the Y. And then so you can have this kind of different uh, mode in the bar plot. You can say bar mode equal to group, and you can plot this as oh yeah, wow, this kind of nice looking plot. So px dot bar df. So what is x? X is medal, y is count. So the color you provide as nation, and so these are your nations, and then pattern shape equal to nation. So this is, I think, based on their flag or some. It's picking up from yeah, from their the, the pattern representing that particular country, and then pattern shape sequence. So this is the shape sequence that you are providing. So you can see that you can use the facet call. So facet call equal to day. So this will basically divide your plots into like different columns represent different days. And facet row also, you can say facet row equal to time. So it is based on, yeah, this should be different themes actually.
Lunch and
And
dinners are in the
yeah,
timing.
yeah, here we have lunch and dinner. And so then x is x, y is total bill, and the color is ochre. So you can also say plot px dot scatter matrix, and this is like, if you remember, we were seeing pair plot and those functions in Seaborn. So this is similar to that, but it is more interactive. Like you can just go here and see, and you can also segregate it using the different columns. So here we are segregating using species, and then you can say px dot parallel coordinates. So what are your coordinates? And so the color again here is represented by species. So labels equal to species id, and so species sepal width, sepal width. So this is dictionary that you are passing, and so we are saying species id and then sepal width. So this is the sepal width, and sepal length, sepal width, petal width, and petal length. So these are the species, and yeah, so you can make this kind of a nice looking plot. And then you can also say parallel categories. So how, like so how many people are actually male and smokers, and this is the day, You can see and the time and the size. So this is Sunday and this is dinner. You can make this kind of plot as parallel categories. And then you have this kind of a scatter plot wherein you can have the size based on a different column, color based on the another column, and x is for example GDP per capita, y is life exp, and then you are extracting the data for the year 2007 and hover name equal to country. So as you hover, it will show you the country and it will show you the information for the different countries. Now you have we also have this animation feature in Plotly Express. So we are getting this data px.data.gapminder, and so you say px.scatter. So this is the data frame and what is on x, y, and animation frame is based on the year column. Animation group is by country, and the size is by population, color is by continent, hover name is according to the country, and facet call is according to the continent. So you are also dividing this based on the continent, and now you can see this. We will run this animation. Then you have these are the line plots, and these are the area plots. So you can see this kind of nice looking area plots we can make, and you can divide it based on the country. Color is based on the continent. So these are all Asia. So these are, and the different lines here represent the different countries. And yeah, so you can also have this kind of different plots. So we will see maybe more of Plotly in the next class. I think this will take some more time to discuss. Yeah. You ready?